So for this one, you make your own large language model, or to be fair, you install one and run it on your own hardware, which is very important, of course. If you use things like ChatGPT or Bard, you're running on cloud servers from a company, and while that's good for a demo, it has some serious disadvantages. One of them is anything you send up to there, you really don't know if it's remaining private. Now, they promise they're not training on customer data, but how do you know that's true? And the next thing is, you probably don't want to use those large language models just trained on random data from the internet for any serious purpose. You'll want to customize it with your company data. And that company data will be used, again, might be exposed. So in reality, you probably want to run your large language models on your own hardware or in the cloud on a machine where you've restricted the access to just your company people. So you want to have your own code. And here's how you can do that. There's these things, a bunch of them are open source, and you can just download them and run them. And this seemed counterintuitive to me at first because the large language models are so big and complex. But the activity that is difficult is training the model. I've seen estimates that it costs $40 million to train ChatGPT. But running it is so simple, you can run it on a cell phone. So because what training it, of course, involves all these calculations and stepping through a high-dimensional space and processing an enormous amount of data. But after it's trained, you're just doing a simple linear calculation. And even though it's probably trained on something like billions of parameters, you just have to do 1 billion linear operations, and that's not too bad. You can do that on almost any kind of computer. So Google Colab is, of course, the cool thing. So here, we just install some libraries and then download and run Bloom. This is the smallest version of Bloom with only 560 million parameters. And because it's kind of slow, I already did the download process. You install some libraries, you download some stuff, and now you can use Bloom. You can just use it right here. So here I can give it a prompt of why is the sky blue and see what the result is. And I will take 50 words. I think it's actually 50 tokens. Large language models don't process words one by one. They process tokens, which are meaningful encodings of words. They're not exactly equal to words, but they're approximately about the same. And so this will take a prompt of why is the sky blue and then add 50 words and give me the next 50 words following that, because all it ever does is predict the next word and do that over and over. And so I guess that just defines the length. Okay, now we're going to try different kinds of searches. Now, a greedy search is where you predict the next word, you consider various options, and you always take the next word that is most likely. So there is no randomness, and it only thinks one word at a time. So the results will always be the same. And as you can see, not terribly brilliant. It'll come up here pretty soon. You see, it takes a little while to run. Now, this is a free Google Colab machine, so it's, I think just got maybe 2 cores of processor and it's 8 gigs of RAM or something. It's a pretty small virtual machine. And here you go. Why is the sky blue? It is, said the girl, but it's not the same as the sky. It is not the same as the sky, said the boy. Pretty much nonsense. Somehow it hasn't interpreted this as a question where I'd like a scientific explanation, but sort of the start of fictional dialogue or something. And this is what it found to be the most common extension to that sort of thing in the data it was trained on the web. And if you run the same thing again, you'll get exactly the same answer, because this is a greedy search. It always takes the most likely word every single time. Now, the next one is using a combination of 3 methods. So let me skip it for now and do the beam search next, because I think the other one is the combination of these two. A beam search looks several words ahead. And someone has posted a visualization of tokens. That's good. In fact, since it came up, let me, I'll start this one running, and then let's look at this visualization of tokens, because that might be good. ChatGPT's tokens. Here we are. Oh, yeah, the tokenizer. That would be fun. All right, so here's the tokenizer from ChatGPT that he put there. Let's try putting in, why is the sky blue? And that's 6 tokens, 20 characters in here. And in this case, it's just word by word. But if you put in a more complicated sentence, I guess it would not be word by word. Let's try one of these sentences. Still, it looks very close to word by word, GPT-3.5. Okay. So this is nice to see how the tokenizer works. That's a good thing to know. I'm going to save that in my links so I can find it again later and throw it in a course somewhere. I got to find the right browser, which is this one. All right. And save it. That's a good thing to know. Tokenizer. All right. A good thing to know. So that's the next one here. This is the beam search, which looks ahead several words and chooses the most likely. And so here again, it's still making some kind of weird stuff about it's not the same as the blue sky. And I think this one also is the same every time you run it. It is the same sky as when the sun shines on the horizon. Beam search, and there is an explanation of beam search here, which I found a little confusing, but it does have no randomization, so you should always get the same answer. Yeah, this stuff about the moon is on it, and something on the horizon, and the moon is in its place. And here's this thing called top K and top P that uses a combination of 3 methods, and this one has some randomness. And that might be these parameters. Now, some of these have a parameter called temperature, which is how much randomness. And this one, it's not explicit, but I imagine these parameters here set that to some extent. Here, I can see a black hole just a few hundred light years out from the galaxy. Okay, so this one babbles about a black hole, but if I do it again, I'll get something different because of the randomness. And the commercial ones like ChatGPT and Bard, they have some randomness built in. That's why Bard will even give you 3 versions, and they give you a different answer each time. And if you make it run there, see now this one is completely different. So at each word, it has a chance of just going off on a different path. But whichever path it starts, it always tries to extend it so that it still makes some kind of sense. But as you can see, it doesn't make much sense. All right, and that's the beam search. All right, and then there's a few flags to find here. Originally, I had flags where you would put in prompts and you'd get the answer because I thought there was no change in these, but they are apparently changing these models. So I switched to just printing out some parameters of the model, which make a more stable flag. So that's the first one there.